So basically, when we say what is parallel computing, we need to understand these 5 questions, right? What is parallel computing? Why it is required? How we can apply this parallel computing? Where we can apply, and when we can apply this parallel computing? So basically, parallel computing that we are going to discuss, but it is very important to understand why parallel computing is required. So to understand why, definitely we want your application or run in very less amount of time. And how, that is exactly what we are going to discuss in this course. How we can write this parallel program, right? Where it depends on the resources. Like you can do parallel computing in your laptop also. You can do parallel computing in your maybe high-end server also, or maybe some simple mobile device also. You can apply this parallel computing, right? When it is very important, we cannot go and parallelize each and every source code from the internet, right? There are some specific limitations are there, right? So your program must that means require a lot of time. If your program is taking suppose milliseconds to execute, then definitely it is not worthy to use this parallel computing knowledge over there. But at the same time, if you see, if your deep learning training requires maybe 5 days to train on particular model, right? So definitely we want to reduce the that training time or maybe inference time using this parallel computing, right? So these are the typically questions are there, and you cannot go and apply the parallelization for each and every source line of your source code. Okay, so there is going to be some portion of your code which is embarrassingly parallel. Okay, some portion of code which is where we are to some modify our code, and we can make it happen to be executed in parallel. And there are going to be some scenarios where it is not completely parallelizable at all, right? So this is very important to understand where we can apply parallelism, when it is feasible to apply this parallelization, right? So throughout this entire course, we can will be able to understand or maybe able to take a conclusion out of these all 5 questions. Okay, you can make decision whether to is feasible to go with parallel computing, right? So prerequisites for this particular course, I can say you must know one of the programming language like C or C++.
Yeah, so
And
on that thing, yeah, I have no knowledge on C and C++. Actually, mine is on Python and JavaScript. I started as a developer,
yes,
then now I'm into machine learning. So C++ is nothing. I don't have
uh,
much
at
experience in it
least
all.
at least you are having some familiarity with C programming language, right? So
Yeah,
you know
it's in college. Yeah.
main main program, how dynamic memory is allocated. That's it. Okay, you can understand the for
Okay.
loops, right? But
Yeah, yeah,
that
those
is the
things I
beauty
know.
of the OpenMP or CUDA program, right? So
Oh,
you
okay.
don't have to learn completely new syntax here. Whatever existing syntax is there, maybe existing programming language like C or C++ or even Python also, you have to modify
Mhm.
some portion of your code, right? Maybe hardly you have to modify, or maybe 80% to sorry 20% to 30% code modifications you are going to do in existing your program, right? So first of all, I'm
Okay,
going to
okay.
write suppose matrix multiplication program C, C++, and maybe Python, right? So
Mhm.
I'm going to do some modifications. Okay, I'm not going to details of how to do that, but by using, if you talk about this OpenMP programming language, by including only 3 lines of code, you can convert your C program or C++ program into your CUDA program, right? Or maybe OpenMP program, which can exploit the computing power of underlying maybe CPU or maybe GPU, right? So again, typically, if you ask the people working in high performance computing domain, they don't go for the Python programming language because of the wrappers, right? So internally, Python is again working on your basically a C program or C++ program, right? So if you want, if you compare the performance, if you use CUDA programming in C and maybe CUDA programming in Python, you will find the difference performance, it will be very there is going to be performance difference. Maybe if you see for same program CUDA program with C programming language, which is going to take suppose 10 seconds, it may happen that similar program in Python with CUDA, it may take almost maybe 15 seconds to 20 seconds, right? So typically, if you want to go for the better performance, people advise that go for the C or C++ programming language, where you can say these are very close to your hardware, C or C++ program, right? Coming to your problem, question is that you want to work in Python. So idea is
No,
here,
actually,
if you know parallel.
I'm kind of even so. The thing is that we have programs written in Python. So currently, we are looking to change it into C also because the performance issue is there in our company. That's
Yes, yes,
we have
yes.
yeah. So yeah, so I think so that's why I thought that this would be a starting step. So I think I'll have to
Mhm.
take up the C course also, right, along with this to make a complete
Uh,
use of this.
I don't see you need a complete C programming course you need to take. Okay, so fundamental concept we know. If you know, but you started your programming using C, right? So here you
Actually,
don't
I am from
require.
mechanical background, so C is very limited. And in school days, I've learned. That's it.
Yes, but it is
It's from
not at all like your very deep depth
the
knowledge of C programming.
pointers and all those things. Those concepts from C, I'm not aware. So is it
Uh,
important those things?
Pointers also very basics
I
of
mean that.
pointers is required. We are not going to handle maybe multiple pointers, and we are not going to
Okay,
handle too much about the pointers. Okay. So
okay,
what
okay.
happens? Maybe if you know the basics of pointer, it is nothing but just to hold the address. Okay, and how to
Yeah.
dynamically allocate memory. That is all required in CUDA programming, right?
Okay.
So again, if you can go and further to be specific to your application, you can, if it is if your organization is expecting your pointers based your operations, then you can explore it. But for my course, it is very less knowledge about this pointers is required, and whenever it is required, I can clarify your doubts regarding that pointers. Okay, it is not that much difficult, and throughout the
Sure, sure.
course we will understand that okay, this is pretty much simple. Okay, just we are using this pointer concept to allocate some memory, right? Okay.
Okay.
uh, and again in Python, uh, one here idea is here, if you know parallel computing or CUDA programming using any of the language, maybe it is C++, maybe it is C, or maybe it is Python. Ultimately, if you want to shift from one programming language to other programming language, parallel programming concept remains same, only syntax is going to vary, right? So if
Yeah.
you understand this parallel computing, I would highly recommend go with C programming, right? Then once your concepts are clear, you know how to call these functions, you know how to allocate this memory and all those things. In Python, maybe you are going to use some different syntax, right? So for example, in C programming, we use some dynamic memory allocation, right? Then in
Okay.
Python, maybe we are directly going to allocate numpy array or maybe cupy. Similar
Yeah.
libraries,
Umpire.
CUPy is there, right? So only syntactically it is going to vary. Otherwise, if you see the core idea of this programming remains same. Okay, how to create number of threads, how to divide the task among the multiple threads, that remains exactly the same. Only syntax is going to be varied here, right? So it doesn't matter. Okay, so in which programming language you are going to start. So typically nowadays, when I used to be there in internship in IIT Bombay, where I worked in mechanical domain. Okay, so probably
Okay.
you might have already heard about this finite element analysis concept,
Uh-huh.
right?
Yeah. Yeah.
Computer,
FEA.
that
Yeah.
CFD, computational fluid dynamics. Okay, I
Yeah.
was
Yeah.
there in, I got hired in mechanical domain department, where I work or I use this CUDA programming language to solve their existing, maybe to accelerate their existing programs from your AutoCAD, or maybe not AutoCAD, ANSYS, right?
Yeah. Answer
So
something.
yeah, so that at the back end, I did the programming in that. So where I worked in C, and if you want, I'll take one or two sessions on how to uh, execute this CUDA functions in Python as well, just for the sake of completion of this course, or if you, in case of your case, you demand for that. Right?
Yeah.
But ultimately, I can say programming strategy remains same, right?
Sure. Yes.
So apart from this programming, you must need some basic knowledge of algorithm. So, typically, we used to think till this date the working of your program in sequential manner, assuming that we are having only a single resource, that is CPU, right? But now, if you
Mhm.
are going to the parallel computing, you have to think in parallel because you will be having multiple resources. Typically, in your system, when we say dual core system is there, quad core system is there, that is nothing but they are having 2 resources or maybe 4 resources, or even you can have 16 CPU resources. Okay, Rakesh, could you please mute yourself?
Yeah, yeah.
Yeah.
Sorry.
And here it is in multiple resources are there. That is, you have to exploit this entire resources by considering it as a single unit, right? So for this, you need some parallel thinking also. And trust me, if you're working in this deep learning domain, most of your operations are related to kind of matrix multiplication, right? Maybe matrix vector multiplication, dot products are there. So basically, you work on the linear algebra, and these computations are embarrassingly parallel, right? So on brief idea, what we can say, if you are going to perform matrix addition, so we can divide, if you are having dual core system, you can divide half of the matrix addition to one core and half of the matrix addition to another core, right? So this is how you have to think in parallel. Previously, we used to say a single core is there which can perform the entire matrix addition. But now, if I'm having 2 resources, definitely I can divide tasks among the 2 cores, right? So this is the how your parallel thinking is should be there when you go for this CUDA programming or opening. In your case, it is very pretty much simple that you don't have to go into too much depth of this parallel computing patterns and all those things. But definitely, I'll go through that parallel computing patterns also, because in future you may encounter such kind of scenario where you have to go from the scratch and code, or maybe you'll get some typically different kind of computations where you can leverage the knowledge of this parallel computing pattern. Okay, we can discuss that in few details, how you can think in parallel, right? So you don't have to worry about this also. Then data structures, as I told you, most of the time we are going to work on your matrix, right? So typically this will be going to be helpful for you also because you are working in deep learning era. So here, data structures in the sense, sometimes we'll be working on structures and matrices, right? Or maybe arrays, you can say. So these 3 data structures are very important for this CUDA programming course, right? In case if you're not able to recall some specific concept in your C, then definitely you can work out that and try to go backtrack and elaborate what are the concept of structures, maybe, or maybe matrices, how it is they are going to be stored, and then we can go further and do this CUDA program. Then computer organization. So these are some basic concepts are there in computer organization. That is clock speed, pipelining, memory organization, that we are going to clear maybe in the first 1 or 2 sessions. Right? It is required. And it is not at all required to go into the too much details again at hardware level, because your domain is not like completely as a solution architect or maybe high performance computing engineer. So here, this domain for you is just add on your existing uh, your software stack. Yeah. Okay. So for that, if you are now from mechanical background, perhaps you already maybe encountered this kind of term, that is what is memory, what is clock speed, and all those things. If at all it is not, you are not able to recall, then we can again go into the much details about what is clock speed and all those things, right? So in this presentation also, I do have some clarification on this concept like clock speed and all those things. Okay, so Let's discuss what is sequential versus parallel work here. So for that, I'm taking three scenarios here. So let's see one by one. In first scenario, let's suppose we are having a task. You are supposed to that worker is supposed to dig a 20-meter big hole. Okay, and here we can focus on resources. So here we are having one worker, that is resource. Then the worker is having one shovel with one tooth, right? So simple shovel is there in his hand, in her hand, and let's assume that efficiency of this particular worker is 1 meter per hour. That means the person can dig a hole with efficiency 1 meter per hour. Now, for this particular task of digging a 20-meter big hole, it requires 20 hours of time. Okay, pretty much straightforward. So efficiency is 1 meter per hour. This scenario is your real life scenario. Now we can relate this real life scenario to your computer as well. Okay, so here I'm trying to relate with your computer system. You can see here when we talk about resources here, we are going to talk about some computational units, that is your CPU. And with respect to your previous scenario where we are having only single resource, that is a one shovel with one tool. Here also we are having single resource, that is single core here. You can see here a single core, right? And its efficiency is nothing but your clock frequency. Let's assume that 2 gigahertz. Don't worry if you're not able to recall this clock frequency and pipelining, we'll go into the details. So let's suppose based on this clock frequency, your efficiency of core or CPU core is determined. Now other parameters are also there which affect the performance of your system, that is pipelining, time prediction, and cache, right? So just to relate with your this real life scenario where we are having limited resources and efficiency is quite low, according to that I tune this kind of parameters here, right? So pipelining is not available, branch prediction is not there, or cache is also very slow. So in this scenario what happens, we are having limited resources and efficiency is low. So that's why let's assume that it requires 10 minutes of time to perform some particular task on this machine, right? So one scenario with real life and one is your computer scenario here system. Let's see now second scenario is here. Here we are having again same task, digging 20-meter hole. Again resources we are having only single worker. But if you see now we updated with that person's tools. So previously single shovel was there, but now we are going to replace it with some mechanical device, right? So here mechanical device means suppose some driller is there or some mechanical tool that the worker is using in order to perform this task. Now, just because we shifted from this shovel to this mechanical device, the efficiency of that person is improved from 1 meter per hour to 1.5 meters per hour. And based on this now, total amount of time required is 13.53 hours. Previously, it used to take 20 hours, right? So what we can conclude out of it, if you improve the resources or upgrade the resources, then also we can expect the performance is going to be increased here, right? So from 1 meter per hour to 1.5 meter per hour. Now entire duration of task is reduced to 13.50 hours. So again, this is real life scenario where we upgraded the resources. Same scenario we can relate it to your computers also. So again, they are having single resource, that is single core, right? But here I'm improving the clock frequency from 2 gigahertz to 4 gigahertz, right? So you can see here I'm providing pipelining also, branch prediction also, and cache size also improved. That is now is large in size, right? So if you compare with your scenario one, here we are having a 2 gigahertz clock frequency. Pipelining is not there, branch prediction is not there, and cache size is also small. Now we improve the efficiency by upgrading the resources here, but single core remains as it is, right? So single core remains as it is, but we just improve the remaining parameters, right? And based on these parameters now, previously it used to take 10 minutes of time, it is now taking maybe 5 minutes. Again, these are the some numbers. So these are not practical, just to demonstrate how the performance is going to change. For the sake of simplicity, I'm using these numbers, right? So this is second scenario. Now third scenario. So instead of using single worker, why can't we use multiple workers together? Again, task remains same. 20-meter big hole we have to dig, and now instead of using one worker, now I'm using 4 such workers. So obviously, for one worker, the efficiency is 1.5 meters per hour. Now, if we combine all these 4 resources together, then the combined efficiency is now, which is going to be 6 meter per hour, right? And the time required to perform this entire task of digging 20-meter big hole now is reduced to 3.33 hours, right? And same thing we can relate to your computer system. Now, instead of using single core, now I'm using quad core. That means instead of using single resource computing unit, I'm using 4 such computing units. Typically, we say that I'm having dual core, quad core, octa core machine is there. So in short, what we are saying, instead of using a single computing unit, I'm having 8 such computing units, where every core is maybe responsible to perform some different tasks here, right? So you can see here, if you relate to this person, the person is talking on phone, working on system, and tapping the dog, maybe scheduling something on calendar, printing something, and putting something in dustbin. So you can see one hand we can relate it to your one CPU core. That is, every core is performing some different task, let's say, right? So here typically we improve or we increase the number of resources or computing units. In scenario 2, we upgraded the existing resources, or sorry, existing single core unit here, right, from 2 gigahertz to 4 gigahertz. But now in third scenario, we are replicating the resources, right? So this is where we can get the maximum performance here. So you can see this is nothing but a parallel work. So every core is responsible to perform some kind of operation, independent operations, right? So by means of this, you can see the amount of time is reached to 1.2 minutes there, right? So basically, I'm trying to relate your real life concept to this computed by. Don't worry, we can discuss what is clock frequency, pipelining, branch prediction, cache. So these are just required to understand the performance. But throughout this course, it is not at all required to go with the every time clock frequency, pipelining, and branch prediction. Okay, these are very computer organization stuff is there. So for programming, it is not at all required, this concept. Just to understand the things, okay, how performance of the system is improved, we can see these parameters. But definitely, cache is somehow is important in case of your CUDA program, where you can explicitly leverage this cache memory, right? So this is about your what is different between sequential and parallel work, and how we can relate it to your real life scenario and computers, right? So now let's discuss about how we can improve the performance of CPU, a single core device, right? There are different parameters that are associated with this improving the performance of CPU. Okay, so this is again just to uh, give you clear idea why we are moving from CPU to GPU. Okay, so it is not at all required to understand this concept. Okay, in order to do some CUDA programming, these are typically some terms the computer scientists use in order to do their system or maybe system specifications, right? So just to give deep idea about what is this particular how we can improve the performance of CPU, then we can see these parameters. We can discuss this clock frequency and others. So basically, what is happening? First, we can program on sequential CPU. Then we can go on multi-core CPU, and then we are going to move towards this graphics processing unit. So I'm just creating path from CPU to multi-core CPU to GPU, right? So you we cannot directly jump on maybe GPU and start programming. So we need to understand some fundamentals on CPU side first, and then we can gradually move towards the GPU. Once we see what are the limitations on the CPU side, then we can understand thoroughly that okay, this is the importance of GPU. So first of all, we'll start with what is parallel computing. Okay, what is computer architecture and everything. And in the first chapter, we are going to see how to write simple CUDA program. Okay, hello world program from GPU. Then it is very important to understand what is CUDA programming model, what is a CPU, what is GPU, brief history of the GPU, the architecture of GPU. We need to understand. Then how we can measure the performance or timing of your functions that we'll discuss. And then how this threads, what is concept of thread and what is concept of process, and how these threads are organized in CPU and how it is different from GPU that we are going to discuss in 1D, 2D, or maybe 3D, three-dimensional blocks. Okay, the thread organization. Then in chapter 3, maybe you can see different architectures of GPU. Recently, we are having architectures like Ampere architecture is there, Volt architecture is there. These are the older Fermi, Kepler, Maxwell are the older architecture. Then the concept of warps and threads that we can discuss. Okay. Then some tools are there where we can see how your program is executing on GPU, that is NVIDIA profiler. That is, we can visualize how these GPU resources are being utilized, that we can discuss. Then some advanced concept like branch divergence. Okay, that is also required. Dynamic parallelism is not at all required in your case if you are working in the domain of AI, but I'll just introduce you to this dynamic programming concept, right? But I don't think we typically use dynamic programming deep learning because most of the computations are only simple matrix select operations are there. Then some different memories are there, like global memory, shared memory, constant memory, and some memory related operations are there that we are going to discuss. So what happens? Not only we are getting better performance with respect to computing units, but sometimes we can get better performance by using this GPU memories, appropriate GPU memories also. Okay, so that we can discuss in detail. Then this shared memory is very important memory in GPU. So whether you are working in C or whether you are working in maybe Python, it is very important to understand this particular concept shared memory to improve your performance further. Right. So typically, in my PhD thesis also, I worked on this particular memory, and based on this, I published few papers. Okay, and this memory is very important to improve the performance of your existing code. Right? We will discuss that shared memory and constant memory in detail. After that, some techniques are there where we can improve the parallelization further. That is streams and concurrency here. So streams concept is there that we discuss in detail, right? And finally, we'll see how to go for the some libraries, existing libraries like USPARS and others. And this very interesting programming architecture is there. That is OpenACC. It is recently, it is again still in development phase, but right now also most of the people are opting for this. So here, this is typically for the people who are not expert in computer science. Okay, this is for people who are from different science or maybe other disciplines where they don't have much idea of this programming, and there we can exploit this OpenACC. It is pretty much very simple to do programming in OpenACC. For example, if you I'll give you one C program. By writing a single line of code only in your C program, you can convert this entire program on GPU, right? So whatever tasks you are doing explicitly in CUDA, those tasks will be automatically executed using this OpenACC compiler, right? The problem with OpenACC, I'm a bit doubtful whether it supports your Python or not. Okay, if you are typically working on CPU side C program, then definitely at the end of this CUDA programming, you can dedicate 2 or 3 sessions for OpenACC. You will find out that the amount of energy you are going to invest on writing CUDA program, that will be reduced to almost 90%, right? So in CUDA programs, if you are writing maybe 10 to 20 lines of code, in OpenACC, it is replaced with only single line, right? So that we can discuss. But the flexibility available in CUDA program that is not available in your OpenSSE, right? But if you sometimes in simple computations, if you compare performance of your matrix, matrix header operation, CUDA and OpenSSE is giving the similar performance. And this is having multiple editions like community edition and enterprise edition, right? So for pre version, you won't get support from NVIDIA if you are stuck somewhere. But if you go for the enterprise edition, where you'll get uh, support from NVIDIA, right? So this is CUDA is freely available, and if you go for the paid version of OpenSSE, it is going to cost more, right? So I'll introduce with OpenSSE also. You will find out that if you go for OpenSSE, your lot of efforts are going to be reduced, right? And for every, you can say, concept, I'm going to discuss with some case studies or maybe some simple assignments. And some assignments I'm going to take in the session, and some assignments or some modified assignments I'm going to give you for your work on your before as a homework kind of, right? And you are not in the plan to go for the Python, but right now, if you want, I can give you some basic understanding of the programming in Python. But typically, our major focus will be on C. You can dedicate one or two, maybe 2 or 3 sessions to how to use parallel computing in Python. Typically, I have never used parallel computing CUDA programming in Python, but in your case, I can prepare for it maybe for 2 or 3 sessions, so that you don't have to worry about how to program on Python because you study in C now, how to implement in Python the same concept. So what we'll do, we will take 2 to 3 assignments that we are going to implement into C programming language. That same assignments we can take in your Python also, so that we'll be having flavors of both C programming as well as Python, right? Okay, so this is
Sure,
about
sure.
content and maybe the teaching methodology that I follow in this CUDA programming course. Apart from this, if you have any doubt, you can ask me.
Yeah, yeah, sounds good. So, like, what will be the duration of this, like, of the whole thing, the program?
Uh, Typically, it requires maybe 20 to 30 hours to complete.
Okay.
But again, it depends on the how much time it requires for you because you are from mechanical background. So this is for
Yeah.
maybe for the people who are already familiar with the C programming and fundamentals of computer science. In your case, it may
Yeah,
be
I'm thinking that I'll take C plus. Is it C or C plus plus? C plus plus is
no
fine.
C program, C program.
Okay, okay. So I'll take a C also, like make a parallel. I'll try to learn that also because we are also trying to move our infrastructure to C plus plus because Python has a lot of limitations in processing speed and those things.
Yes, yes, yes,
So
yes, yes.
it's some of the algorithms in our company it's taking like one day deep learning thing,
Yes,
and
yes, I
the
can understand
when
your pain.
when you execute the model, it is like it's very slow.
Mhm.
So
Yes, yes,
so
yes.
that is an issue we are currently facing. Yeah. So I'm thinking that I'll just move to
Yes.
C plus. I mean, yeah.
No,
So C
to
plus plus and
understand
C is
this
like
CUDA
almost same,
programming,
right? Yeah. Yeah,
uh,
yeah. And
we can say that in C++, we are talking about more about your object-oriented programming and some standard template libraries are there. Okay. So,
okay.
but ultimately programming, CUDA programming is going to be the same in both cases. Okay, whether you go with C, C++, and CUDA, as I told you, where only syntax is going to differ, and your core concept of your parallelization remains same. You can go for the C++
Okay.
just because we are having object-oriented flavor is there, some standard template libraries are there. For that reason, you can go for C++.
Yeah.
Typically, uh, the code is not going to change related to CUDA program in both C, C++, right?
Yeah.
But if you're,
And how is the yes, yes.
yes, yes, go on.
Yeah, so I was thinking like that, like if when we change our like currently it is in Python, so when we change it just the code in C plus plus also there will be some much better performance, right? And just to simply when we
Yes,
migrate from Python. Yeah.
Yes, yes,
So
yes.
and when we add CUDA programming is like it will be working in the like a parallel computing will be also added like a multi-threading. That is what that's what
Yes, yes,
it
yes,
is.
yes.
It
So,
okay.
uh, if you see Python, Python is, I think, the base it is C program, and on top
See,
of it some
yeah.
C++ is there, and on top of it your Python is there. So to communicate with your hardware, you have to go with some layers, right?
Yes.
So if you see in case of C or C++, these are very close to your hardware. Okay, there are no some wrappers and all those things. So it is very close. So definitely, if you compare Python program and your C++ program, some performance improvement you can observe. But if you go beyond that and you can leverage or you can include this CUDA programming on top of it, then you can see the drastic improvement in your performance. Maybe from one day, for example, right now I'm working on one typical model in case of the machine learning model. I think it was PCE is there. PCE, I think you have heard about it. PCE algorithm. Okay. So
Uh-huh.
dimensionality reduction and visualization problem. So I was working
Okay.
on 10,000 data points where it was taking 18 minutes to for moving from I think 560 dimension to two-dimensional space, right? And
Okay.
now I have use some GPU framework, that is Rapids framework is there for handling this kind of models. So it is executed in I think maybe 30 seconds or 40 seconds, right?
That's a
So
drastic change. Yeah.
yes, so I think almost I observed 100x times better performance, right? And this is
Sure.
only I was working on simple data set that is 10,000 data points. In your case, you'll be working on maybe millions of data points or even billions of data points, where you can see one simple k-nearest neighbor algorithm gave 600 times better performance. That means suppose it is
Okay.
taking
Okay.
maybe 60 or 600 hours, now it is going to be done in only 1 hour. Right? So that kind of
Yeah.
benefit we can expect from this GPU side, right? And uh, if you go for this C++, then definitely in our session, we are going to talk about more about the C programming because it is very easy to understand this CUDA programming using C syntax. Okay, same syntax, or maybe in case of C++, we want to be make maybe a little bit different syntax, but their functions or programming strategy to exploit the GPU remains same. Okay, barely
Yeah.
few changes, obviously, and the same with respect to Python also. So I would highly
Okay.
recommend
Okay.
if your organization wants to be convert your models on C++, then definitely I would recommend start C++. Okay, but to understand
Yeah.
C++, it is going to take bit time, right? So like
Yeah.
your
That's
C,
what. That's what. And me coming from mechanical, it's little hard.
yes. So even if you are from mechanical domain, you can learn C programming in hardly maybe 15 days to 30 days. But for
Yeah.
C++, it will take bit time, right? So,
Okay. Okay.
so if ultimately you are going to uh, shift to C++, then I would recommend start C++ directly. Some fundamental course of
Yeah.
C++. Right?
Because why? Because there is not much library in C. I think for machine learning and deep. I
Yes,
mean deep learning.
because
Yeah.
lot of things related to your objects and all those things. Right? So
Yeah. Yeah.
object-oriented programming there. So C++ is widely used. Right?
Yes.
So, but if I start C++ in this particular session, then it is be difficult for you to digest this CUDA programming because C++ is also there and CUDA programming is also there in parallel. Right?
Okay. Okay.
So my suggestion is even for the people who are expert in computer science domain also, I start with C program because uh, anyhow we are starting new programming language and I don't want to get confused or maybe putting more energy on C++ part and maybe similar energy on CUDA part. So
Yeah. Yeah.
C
I think that
programming,
is fine too.
yeah,
Yeah. Cause C would be fine. I think it would be easy also, right, to learn. I mean,
yes,
as
yes,
far as C plus plus is concerned.
yes. And for this particular course, if you attend maybe any YouTube tutorial for C programming. Okay, maybe 15 days of time. So definitely you can grasp almost every concept here. And still, if you're not
Sure,
able
sure.
to recall any typical concept from your C programming, then I'll try to elaborate in much detail here also. Right. But
Yeah.
it will be better if you learn C programming by yourself so that you can invest your more time on CUDA programming. Yes.
Sure, yeah,
And
that's what I was thinking. Like,
yes.
If you like our videos, then subscribe to our channel and be a part of the journey with GoLogica and stay connected with the latest videos.